okay? So today I'm going to talk with you about moving beyond the hype of micro frontend and addressing the challenges in large scale. As companies grow and face the challenges of managing large-scale web application with multiple teams, the interest in micro frontend is rising significantly. As you can see in this image showing the micro frontend web search term over the past 5 years on Google Trends. Let's see some statistics and insight about micro frontend as of 2024. 2024 survey by State of JS reported that over 30% of large-scale web applications have adopted micro frontend architecture. This is a notable increase from last year when they reported about 22%. Additionally, a State of micro frontend reports that 65% of teams using micro frontend experience improved collaboration and reduce the friction between teams. When working with micro frontend, teams now can work in parallel on different parts of the application, and they can reduce the dependencies between the teams. And last one, a research by Dizon states that 55% of enterprises using micro frontend reported improved scalability, faster iteration, and better management of their UI component because they start to use reusable components and design systems. I will introduce myself. My name is Roei Berkovich. I've been a software team lead at AppsFlyer for the past 5 years. I mostly work with React, Node, and the JavaScript ecosystem. You can find me on LinkedIn, X, Twitter, and GitHub, of course. So you can feel free to reach out or DM later. So today I'm going to talk with you about micro frontend. We will do a short review. We will talk about the benefits. We will talk about the challenges in large scale and what we did to manage it. We will see some tooling, and we will recap at the end. So micro frontend, what is it? Micro frontend is an architecture style that divides the web application into smaller, independently developed and maintained components. Basically, we take our app and break it to multiple services that deployed independently, and you don't need to know what other teams are now doing. For example, on the right, you can see the UI composition. We break it to 4 pieces. We have the shell, the host application, that render a Vue application, Angular application, and React application. It can be all React, it can be all Svelte, it depends on your configuration. But when you have a new feature on the React service, all you need to do is to develop it, test it, push it to production, and that's it. You don't need to take care about the other parts of the application. What are the key benefits of working with micro frontend? First, independent deployment. Each micro frontend module can be deployed independently of one another. Scalability, much faster iteration. You can reduce bottlenecks. You don't need the order of the deployment on Sunday, on Monday, Tuesday, and you need to run tests because other team just pushed their code. And you can isolate your failure much better. What leads me to autonomous teams. Now that you don't need to do it, your team has the autonomy to choose what to work with and how to manage your services. Technology agnostic, different teams can use different technologies. You can use different frameworks, you can use different libraries. It depends on you. And incremental upgrades, easy migration. You don't need a full rewrite. You can choose one part to rewrite, do it, push it, and you finish. So that sounds amazing, right? Let's all embrace micro frontend. But I want you to know that micro frontend is just a tool in your tool belt. And it comes with challenges that you can't anticipate in the beginning because it's a really, really big change. I want to give you some context about AppsFlyer. We have more than 400 engineers in our R&D that operate in autonomous squads. We have more than 1,000 microservices handling over 3 million events per second. And we have more than 75 micro frontend services. So I hope you all agree that this is quite a scale, but we have challenges and it wasn't that easy. The main challenges we encounter, and this is the main 6. If you want to talk with me later about more, but I don't have time to talk about everything. So first, roles and responsibilities. One of the core challenges in micro frontend is determining who is responsible for different aspects of the application. You must determining boundaries between the shell and the individual micro frontend. And just for you to understand, at AppsFlyer, this is the shell. You have the top bar and the left side menu, that render each individual service. So at AppsFlyer, we have a PLG team, we have design system team, we have 3 staff engineers, and we have 1 front-end software architect. It's about 10, 11 people that together are responsible for our infra, that is basically the shell and the shared libraries. They are responsible for rendering the independent micro frontend. How we do it? All of our services must use the same library to bundle the service. That's why we have a consistent library to do it, because we want not to break our application. We also have shared libraries for everyone use. For example, monitoring, analytics pixels, session recording, and localization. When you want to implement, for example, monitoring, you have 2 choices. You can do it on each and every single micro frontend, or you can do it once on the shell, and then everyone will benefit from him and get it out of the box. So we decide to implement it on the shell side, and everyone will benefit from it. The top bar and the sidebar responsible for drilling the top level state to the services. And of course, if we have a feature request from product, etc., they are responsible for doing it. Design system, we build a shared component library, and we have a dedicated team that's responsible for it. And we have 14 teams that develop and maintain our services. Now, each service and each team can decide on its own service. For example, each service can decide about is ESLint rule, pre-tier rule, routing, state management. Each team can decide if they want to work with Svelte or React or web component, whatever. They can choose if they want to work with TypeScript or JavaScript, testing library, HTTP library, how they work with our API gateway. Everything, it's on the team side. So after we understand who is responsible for what, when user navigates between our pages, the user doesn't care that you are now working with micro frontend. The user expects to see the same button over and over again. The user expects to see the same input and the same error over and over again. And this is why you must have a consistent user experience across all of your application. That's why we build a shared component library that's consumed by all services. This is mandatory. No one can say to himself, I don't want this MUI 5. I don't like it. I want to install something else. No, you can't. You must work with the design system. We use Storybook to represent each component and its states and its different behavior. It's kind of the documentation. I hope you are all working with Storybook. And very, very important, documentation. When you have 400, even 100 engineers that needs to work with the same design system or with the same shared libs, you don't want that every day 10 people approach to you and tell you, it doesn't work on my machine, what can I do? Or they will open a Jira ticket, the library doesn't work. So documentation, good documentation is very good. Also, we have a design system team. for fonts, color, and measurement unit. You can just say, okay, I'm writing padding right 1 EM or 4 pixels. No, you are using theme spacing, we are using palette, theme, color primary, secondary. We don't use specific hard-coded fonts, measurement units, and colors. Manage version, we use automatic tools for releases, like semantic release and commit lint, because we want that everyone will work at the same way. And it helps us to isolate CSS. When you combine everything to one single application, you don't want that your CSS will clash between services, so it's very important to isolate your CSS. Next is dependency management. When you have so many JSON packages, some services may rely on the same dependencies, but with different versions. It may lead to conflicts, duplication code, or unexpected behavior when you combine all the services into one single application. So we want to avoid it. So first, for external dependencies, we always want to update our dependencies, and we also have automatic tools that scans our repos and merge requests, and if they identify that you have a vulnerability or security issues, you can't merge your branch and you can push to production. Testing, testing, testing. You must ensure that you don't break front-end functionality. That's why each service writes its own unit test and integration test. And on top of that, we have end-to-end test for the shell plus the services that are run every hour. I don't remember. But it's very, very important. Otherwise, you don't know if you break something. And sometimes you have pages that you don't know that you need to test because we have so many services. When we upgrade one of our libs, we are doing it gradually. We start with the shell and then the infra services. Only then we encourage teams to be early adopters. If we find a bug, it's great. We can quickly fix it, and next consumers will enjoy from a better version. And we understand that we need to think very carefully who is responsible for what, because we want easy control and updates. Another thing is deprecation. When you have a library that's consumed by 75 micro frontends, you can just tell, okay, next week I'm going to deprecate these libs, everyone go and upgrade. Teams have sprints planning, have quarterly planning. You must understand that this is time consuming. Deprecating a library can take 3, 4, 5 months. So keep it in mind. Next, load time optimization. When using micro frontend architecture, you may harm your web application load time. And I will explain. Now you need to fetch and render multiple services at the same time. You probably send much more API requests. This is the API request, huh? But you need to manage it and you need to be aware. If you will compare the load time before micro frontend and after, you can find out that your load time has worsened. So that's why always write your libs in a tree-shakeable way. We don't want unused or dead code in our bundle. Use external tools to analyze your bundle. Before you choose a library, you can use Bundlephobia, and please know a good bundle analyzer that you can work with. It's very, very important that you can understand why your bundle is so big. Code splitting is your new friend. If you are working with React, if you are working with Webpack, whatever, you must split your code. You don't need to download all the code at once, especially when working with micro frontend. Serve your assets from CDN, fonts, images, etc. Use multi-region, whatever your CDN has, and send it to your user much, much faster. Monitoring your web pages. when you monitor your pages regularly, you can create an alert and send it once your page starts loader than usual. You can choose if it will be 10%, 20% more, and get alerts. Whenever you can, share dependencies between micro frontend. It also reduces your bundle size. And leverage HTTP2 for code push server, multiplexing request. It will help you as well. Next one is knowledge sharing. When you have so many developers and so many teams, it's common that someone will start to work on something that other team or other developer has already done. So we can't follow up with everyone's work. And to be honest, we don't know all the developers in the company. So it's very, very hard. We know how to code, but we want to avoid repetition. We want to learn from others' challenges. We want to hear about interesting libraries, POC that has been made, etc. So that's why we have the AppsFlyer Frontend Guild. The guild is responsible for our bi-monthly session. During this session, developers share their work, share their passion, talk about interesting things they've done, and show us some demos about cool libraries, because we all want to learn and to be up to date. We also have 4 guild masters that are regularly work with the teams, because we want to ensure that everyone is aligned with the company standard and continue to grow. When a new developer joins AppsFlyer, he firstly on board with our frontend guild, because we want him to be familiar with how we work and the tools we have, and he have some exercise to do. It takes about 1 month, and only then he joins his team. And we have a cross-company task that we want that developer will take wider task and help for everyone for our common library. Another great tool is SourceGraph. SourceGraph is a tool that scans all the company repos and allows us to search and quickly find relevant information. We can filter by groups, by domains, by languages. For example, I want to start to work with, I don't know, Axios. I can write Axios in SourceGraph, and I will get all the repos that use it. Then I can see how they use it, what they do, and I can decide if I want to use it that way. Maybe I can see that no one uses it. I can ask why, etc. So this is also a great tool. And next up is debugging and monitoring. When you have so many pages and so many developers, you must monitor your pages. You must get traces. At AppsFlyer, we are working with Datadogram. You can choose other SaaS, but we decided to work with it. It's not cheap, so just be aware. But Datadog gives us this dashboard. You have so many data about your users. This is from real users, okay? You can see here, for example, core web vitals. You can see your asset size, how much time it takes the DOM to complete. You can see your bundle size. You can see your client error, your server error. You can see your heaviest resource. For example, I don't know, developer upload a 10 mega image, and he didn't notice, okay? You will see it very, very quickly. You can even make an alert that will trigger if someone push image above, I don't know, 200 kilobytes. And you can see your user session and tracing. Datadog works both for backend and frontend, so we can see a full life cycle of a user. It's really, really amazing for debugging. So this is how a log looks. It's very, very clear. Profile is not defined. You can see the file name. You can see the line number. You can see what happened. and you can go and reproduce the bug. And if you can't reproduce it, you have more data. You have the geo, you have the device type, the operating system name, you have the browser name, browser version, and you can go reproduce the bug, fix it, deploy it, and then you can see the drop in your logs. It helps us to quickly identify front-end issues like error, bugs, bottlenecks. We can pinpoint impacted customers, and what I like the most, that we can resolve error even before the users notice. For example, on the left side, you can see a sudden increase in bundle size. When we saw it, it was very, very easy to find out why. On the right, you can see the actual Git commit that led to it. And from here, it's very easy to investigate, to understand why, to fix it, push it to production, and to see the drop in your bundle size. At AppsFlyer, we utilize the ability to filter resource measurement by page name. All you need to do is to click on the dropdown, choose your service name, and you will get everything you just saw out of the box. So I really like to work with this tool. You can also create alert based on the data you have on Datadog. For example, you can trigger alert once your page starts loading slower than usual. Then you can send a push notification to your Slack channel or team channel. And then, I don't know, the PD or something from your team will investigate it and see what happened. So these were the main challenges we encountered and what we did to manage it. But we are not stopping there. We want more, so we created an internal tool called Sunlight. Sunlight is basically scans all our repos, all the company repos, and their package.json, and we aggregate the data and serve it to our UI because we want to track our migration progress. We want to see if we are aligned with the company needs, and if not, we want to spot where are we weak and how we manage it. We also want to see all our packages version across all the company because we want to see if we are using any old version, maybe security vulnerabilities, etc. And we also score the teams based on their task completion because if you want, no one wants a low score that everyone sees. And you have a list of the teams at AppsFlyer. So we think that will encourage the teams to make the migration much, much faster. And maybe they didn't aware of this, so we can approach them. For instance, this is how a migration from Enzyme to React testing library looks. And if you will click on the gray area, we will see the teams that still didn't do the migration. We can approach them, we can tell them if they need help, or they just didn't do it yet, and they will do it in the next sprint, for example. So after we talk about everything we faced with, when to consider choosing micro frontend. As I said in the beginning, it's not a silver bullet, and it comes with some challenges. So if you have a large, complex application with multiple teams, and the teams are working on different parts of the application, if you have a frequent deployment needs, I can tell you that, I don't know, 5, 6 years ago, we have a deployment order. Today, this team can deploy between 8 to 3. Then other teams can deploy, etc. And it's really, really hard because every time you need to run tests, run end-to-end tests, make sure that everything is working, and it's very, very time-consuming. If you have different technology tools, or if you want to work with different technology tools, like you want to move from, I don't know, AngularJS to React or whatever. And you must ensure that you have resources and skilled people available. At AppsFlyer, we have 10 people that work on the shell and the infra, because if you're working with micro frontend, you need something, you need team to work on the design system, the shared libraries, and what I just talked about. So you need to be aware of all of this. So let's recap. We talked about what is micro frontend architecture. We talked about the advantages. We saw the challenges in large scale. We saw some tooling. And we talk about should we consider moving to micro frontend. So that's it for today. Thank you very much. I hope you enjoyed.